Computer. So now read this section of the code that should input 10 positive numbers and output the smallest number. Output the smallest number input. So from those 10 positive numbers, we should output the smallest. Now small is equal to 0. Count is equal to 0, which is fine. Because we haven't entered any number. We haven't cleared. Are you there?
Yes, sir.
So what I wanted to show you here, this is what you can do if you want to see how the program is working. So I've got small here. I've got counter. So we are setting them to what values at first? We are setting them to 0, 0. Huh? Do you agree? This means
Yes,
we are
sir.
setting them. Then repeat, input a number. So give me any number. So this will ask you to input a number. Give me any number. Any number.
15.
What?
15.
Okay, 15. So let's say we input 15 here. Then you go to line 5. If number is less than small, if number is less than small, the number is 15. It's not less than small. Then number is equal to small. So it means if number is less than 0, or if number is less than small, so it's not correct. Count is equal to count plus 1. Print. So count is equal to count plus 1. There is now 0 plus 1. Print small. Until count is equal to what? Until count is equal to, so there are some errors here. We want 10 positive numbers. Clear? Positive,
Yes,
what is
sir.
a positive number in this? A positive number is any number greater than what? Greater than 0, do you agree?
Yes, sir.
So so there's a mistake here. Well, now if you're saying if number is less than 0, is less than small is 0 here. So we are accepting negative numbers here. Then number is equal to, that's not correct. Huh? Clear? Is that making sense?
Yes, sir.
So look at how I'm going to correct this. I'm going to say if number here is greater than, let's do this. If number is greater than 0, both small is 0. If number is greater than 0, then number is equal to small. So our small becomes what? Becomes 15. Do you agree? Can you see that?
Yes, sir.
Count is equal to whatever. So then there's a problem here. Because immediately it prints small, but we haven't done the 10 numbers. So this should be outside the repeat loop. It should be at the end. Because we simply want to print the smallest number at the end. So give me any other number. Let's continue here. Since our count is 1, we want to reach 10. So this here has to be corrected again. So that count is corrected. Now give me another number. Any number. We are on second number here. Let's say 23, for argument's sake, the input number 23. Now, if 23 is greater than small, so we have a problem now. if 23 is greater than small, then the number, it worked because it was 0. So now it's no longer working. Because we are saying if 23 is greater than 15, because small is 15, then small, no. That's not correct. Huh? Clear? So how should we correct that? We must have a check here that allows us what? To input positive numbers only. Clear? Is that making sense?
Yes, sir.
So let's see how we can correct that. How we can sort out that error. It's just logic, basic, it's not programming, it's just to think the basic logic of such questions. So now let's analyze this and see how we may sort it out. So it's obvious the first error is line 5. Are you there? Now let's see here how we can sort this out. Read this section of code that should read 10 positive numbers and then output the smallest number. So one way we can do this, let me show you here. We can even change line 1. Clear? So line 1 here, instead we can now set small is equal to 999, like a big number here. Let's see if it works. 999. Then this part here, we don't change this. This here. Then we're saying whatever number you said here, 15. If 15 is less than 999, then 15 becomes a small number. Then count is equal to count plus 1. Clear?
Yes, sir.
Then this part here, there's something wrong with this. Remember, okay, let me explain further here. If in computer science here we say, let's say x is equal to 5. Then I say let me use the word num, what you used. Then I say x or num is equal to 10 plus 5. Okay. What I'm trying to explain here is the challenge with this here, you have to be careful. What we want to remember, if the number is less than this here, then it becomes small. But if we do this here, it takes the value of, this means the value of small here becomes the value of the number. How is it? If I say num is equal to small, whatever the value of small, it becomes the value of the number. That's not what you want. You want small to be equal to the number that you entered. Clear? Is that making sense? Small is 999. But now if I enter a number less than that, it rewrites this here. That's what you want. So that number there becomes like that. Are you together?
Yes, sir.
So what it means is that line 5, it has to be if number is less than small, which is okay, then small is equal to none. Clear? Then we say this should be until count is equal to 10. So line 7 should be after until. Right. Clear? Then the last one is that line there until line 8 should be until count is equal to 10. Clear? Either.
Yes, sir.
The more you practice, then the more it makes sense. Now let's look at this. The flow chart inputs the weight of a number of parcels in kilograms. The parcels weighing more than 25 kgs are rejected. A value of stops, it means it terminates the program of -1. Now, let's see how it works. So start, reject, total is 0, reject is 0. Okay, clear? Input weights. So now, when we have this, we always have like this. So input weight, what is the weight? So what is the total? 0, reject 0. Do you agree? There. Set, this means assign 0 to the value to total. Assign 0 to reject. Clear? We haven't added any weight, so those values are 0, which is correct. Now weight is 1, what? 1,8. I'm sure you can see what's happening. Do you agree? Input weight there. What happens? Is weight equal to 1, is weight equal to -1? It's a no, because it's 1,8. Huh? Do you agree? Either.
Yes, sir.
Now what happens? Is weight greater than 25? It's a no, huh? Because it's 1, what? It's 1,8. Huh? So what happens? Total is now equal to total plus weight. Total is now equal to total plus weight, 0 plus 1,8. It becomes 1, what? 1,8. Remember, we are rejecting 6 above 25 what? 25 kgs. Huh? Next one, we go back to that 26.0. Because you see, after we have done that, that arrow shows that we go back. Input weight. Is weight -1? No. Is weight greater than 25? Yes, huh? Because it's 26. So reject is equal to reject plus what? Plus 1. Huh? Reject was 0 here, so it's 1. Clear? Happy? Are you there?
Yes, sir.
Now, next weight is what? 7. Now, what I need to mention here is in terms of doing the table, I should not do this here. Let me show you. something. Let's go back. So what you need to do in terms of course, they don't penalize you what they've done, is since you have one, you accepted one here, if I'm correct. We accepted one because the weight was 1,8. Now the next weight here, we don't want to put it in this line, we'll put it there, which was 26.7. So this here is above 25. It adds our rejection like that. Clear? Making sense? Then the next one is what? Is 7. 7 will be accepted because it's less than 25. We now know what's happening. What's 1,8 plus 25 becomes 1,8 plus 7, sorry. 8, what? 8,8. Huh? Then let's do the next one, 11,3. You now know how the flowchart is working. So 11,3 is less than 25 kg. So it means it's what? It's accepted. Huh? So you add to this. What's 8.8 plus 11,3? So if you understand how the flowchart, you can actually do it without going there. What's that? Add, use your head. You're not allowed to your calculator. 20,1. 20,1. Either. Then 10. 10 again is less than 25. It's accepted. You add to this here. It becomes 30,1. Then after that, you've got 2,5. Again, it's less than 25. It's accepted. So add to this. You end up having 32,6. Huh? Then the next one is 25. What's wrong with 25,5 is greater than what? Is greater than 25. So it's rejected. Huh? The rejections become what? Become 2. Is that making sense? Then we go to 5. 5 is accepted. Add 5 there. Becomes 37.6. Clear? Then we have 19,8. 19,8 according to our flow chart is accepted. So add 19,8 here. 37.6 plus 19,8. Remember, another out the calculator. 4 carry 1. 16 plus 1, 7, 4. 54.7. Clear? Are you there? Next one is 23. 29,3. Above 25 is rejected. Heavy. The next input is -1. What does -1 do? Let's go back to the flowchart. What happens is -1. It terminates the program. Huh? Output total, output reject, end the program. Output total. So under output, what is the total? 57.4. Oh, like this, comma. How many rejects? 3. Can you see that?
Yes, sir.
It's not difficult. That's how you do that. Now, 5 data types and 5 data symbols are given. An integer is a whole number. Sure, you know that from your maths. An integer is a positive or negative whole number. A char is a single character, like your A, your S, that's what char. A string is a string is a group of characters, like your words. Clear? Are you there?
Yes, sir.
Wait a moment, that's not correct. So 12 here is the string. Boolean is yes or no, like true, 0 or 1, only 2 values. That's what Boolean means. Clear? Then real here means your numbers, including your fractions and decimals. That's what real means. Clear? Real. or sometimes they use double. It allows you decimals, it allows you fractions, any real number. Clear? Yeah, then?
Yes, sir.
Explain the difference between a variable and a constant. We talked about what is a variable. A variable is used to store values that can change during the running of a program. How will you get that? A constant never changes. Fixed value that never changes. Clear? Throughout the running of the program. Like your pi running of the program. Clear? It's a fixed value. Variables, they are always changing. Clear? I think. For example, if I say input x, input y, then I say sum is equal to x plus y. Are you following me? Then I say print sum. The value of sum depends on what values of x and y you are inputting. So this is a variable. Are we together? That making sense? The sum is a variable because each time you run the program, you can put different values of x and y. So the sum will always change. Is that making sense? The x and y are also variables because it depends on what values you enter. Is that making sense?
Yes, sir.
Now, if I now say here, if I now run a different program and I say pi is equal to 3.14, then I say volume, let's say it's volume of a cylinder, is equal to pi r squared h. Then I say inputs are inputs h. So these two here are variables, depends on with what you enter. But there's a constant here. This is a constant because it's not changing through the value of pi each time I'm entering here. My program is using 3.4, 3.14. So that's what we call a constant because the value never changes through the running of the program. Are we together? Your radius and your height are variables because they change. You can put any values. Are we together? Is that clear?
Yes, sir.
Now, identify 3 different loop structures that you can use when writing pseudocode. So this you now know we can use a repeat loop, repeat until. You can use while do loop. You can use the for loop. Huh? You agree? Databases, we'll skip them for now. We'll do them later. Come back to them. Now let's go to this next section. Then I'll give you what. So let's analyze it. Read this section of code that should input 30 positive numbers and then output the largest. Yeah, there. We haven't lost you. Output the largest. Well, large is 999. Let's see how if it works. Counter is equal to 0. Well, large is greater than, well, counter is greater than 30. So there's a problem there. Because we only want 30 positive numbers. Huh? Okay. Counter is counting the numbers. Either. So the first line is wrong. Line 1. You see why it's wrong. So large should be equal to 0. Then let's see what happens. Then line 3 here is not correct. It was a 1/3 number. So line 3 should be while count is less than 30. It stops when count is now equal to 30. Do input number. If number is less than large, if number is greater than what? We want number to be, remember large is 0. If number is greater than large, clear, then large is equal to number. Happy? Line 6. That's the only correction. Line 6. If number is larger, is greater than large, number is greater than large, then large is equal to now. Are you following? Count is equal to count. What's wrong with this here? Count is counting how many times numbers you're entering. It should be count is equal to count plus what? Plus 1. So line 7. Line 7. Counts. Count is equal to count plus 1. Counter is equal to counter plus 1. Clear? And while loop print at the end, that's correct. Once it's done the 30 numbers, then it prints the largest number. Heavy?
Yes, sir.
Now, the flow chart below inputs 6 single-digit numbers. The predefined function mode gives you the remainder. So let me explain further how it works. So if I say 5 mod 2, I'm saying 5 divided by 2. What is the remainder? Isn't the remainder 3? The remainder 1, sorry. It goes 2 times and the remainder is 1, clear? Because the mod gives you the remainder. Just like 10 divided by 3 is 3, remainder 1. If I say 7 mod, you're following? Mod 4, the answer is what? 7 divided by 4 is 1, remainder 3. So mod always gives you the remainder. Are you there? Yeah, there.
Yes, sir.
So input, we need to input values A, B, C, D, 1, 2, 3, 4, 5, 6. Let's go and do that. Up to F. So set here, set of values 5, 2, 4, 3, 1, 5. Yeah, happy. Now let's go and see what happens. Total is equal to A times 1. A times 1. So let's write our values here. A, B, C, D, E, F. It's easy there if we write the values. So what do we have? We've got 5, 2, 4, 3, 1, 5. 5, 5, 24, 3, 1, 5. Yeah, they like this. Now that makes it easier. So now let's do the calculation here. A times, it means 5 times what? 5 times 1, which remains 5. Plus B is what? 2 times what? Times 2, clear? Plus C is what? 4 times what? Times 3. You're following? Plus what is D? D is 3 times what? Times 4. Clear? Plus E is what? E is 1. Do you agree? Times 5. Are you following? The F is not involved. So now, let's do that. So that's 5 plus 4 plus 12 plus 12 plus 5. 5 plus 5, 10, 24. 24 plus 10, 34 plus 4, 38. Do you agree? So 38 here. Have you? Then check total mod 11. So we're saying 38 mod 11. Remember how many 11 goes 3 times? Remainder what? 11, 33, yeah? 3 times remainder 5. So 5 is the answer on check. Do you agree? 5 there. Are you there? Are you still there? So our is 5 here. Is check equal to F? Is check equal to F? F is 5, huh? Is check equal to F? It's yes. Output accept. So it's in quotes here. It means we print what's in quotes. Are you still there? Accept. Hello?
Yes, I'm still here.
Okay. Because you have to. Now, 2. Oh, sorry. Let's do this together. 3, 2, 1, 0, 7, 3. 3, 2, 1, 0, 7, 3. So now, let's do that. So this is actually very easy. Just a matter of doing things properly. A, B, C, D, E, F. So we have 2, sorry, 3, 2, 1, 0, 7, 3. So let's use that formula here. Total is equal to 1A, which is 3 times 1, plus B is 2 times 2, plus C times 3, so that's 1 times 3, plus D, which is 0 times 4, which is 0, plus E, which is 7 times 5. So the first one is 3 plus 4 plus 3 plus 0 plus 35. Clear? 5, 4 plus 3, 7 plus another 3, 10 plus 35, 40 what? 45. Are you happy? Total is 40 what? 45. Clear?
Yes, sir.
Now, what happens? Check. It's 45 mod 11. So how many times does 11 go into 45? Isn't that 4? Remainder what? We're interested. Mod gives you the remainder. Remainder what? 4 times 11, 44. Remainder 1. So the check here is 1. Gives you the remainder. 1. Clear? So our check is 1. Our F is 3. So is check equal to now? It's a no. So it rejects because they are not equal. Clear? Are you there?
Yes, sir.
So what is the purpose? I think that's the next question. What is the purpose of the flowchart in part A? The purpose of the flowchart. The purpose, and is 1 mark, is simply to do a check digit calculation. Huh? The check digit errors that you learned in data transmission clear. Check digits calculations. All together for checking errors in transmission. Identify a problem with the flowchart. So those are the tricky questions. Identify the problem with this method. You're dividing by 11. So what could be the problem? What do you think? What happens if I've got a remainder of 10? If I've got a remainder of 10, I'll have a problem. Because we are only assigning 1 digit. Is that making sense? We are only assigning 1 digit to the check. Check is only accepting 1 digit. So if it's a remainder of 10, it's 2 digits. Remember, if you're dividing by 11, it's possible to get a remainder of 10. Is that making sense?
Yes, sir.
So, your homework, children submit tomorrow before Wednesday's lesson, is to do this number 4 here. Number 5, you skip this here. Then you do this question, identifying the errors. And this one here. So that's your work. So try those questions. Maybe print and work on the other paper. Yeah.
Yes, sir. I didn't quite get which numbers you said, sir.
Let me go back. So we said starting on page 11, number 4. Then number 5. Yeah. Page 11, number 4 and 5. Then we skipped this one here. Then we went to page 15, number 2. Page 15, number 2. Then page 17, number 3. Everything on number 3. Yeah. Yeah. Up to page 18.
Yes, sir.
So we'll see you later. To submit before.
Thanks, sir.
You're welcome.